Question 1. When considering a retrofit for a 30-year-old split AC system in a commercial building, Mr. Lewis notices the condenser coil fins are severely corroded and airflow is restricted. Energy audits show high usage during peak load. The owner prefers minimal downtime. Which approach best balances efficiency improvement, system longevity, and disruption? A. Clean fins, add supplemental fans, and continue operation. B. Replace only the condenser coil with an OEM part. C. Replace the outdoor unit with a HVACR condenser compatible with the existing evaporator. D. Perform chemical cleaning and add an economizer system. Answer. Correct answer. C. Replacing the outdoor unit with a HVACR condenser maintains compatibility with the indoor coil while significantly improving efficiency and reducing energy costs. Cleaning or partial repairs D may temporarily help but won't address aging components or refrigerant and efficiency. Economizers D are unsuitable for this low profile and climate. Industry guidelines RE matched stress matching new condensers with existing coils when full replacement is impractical, ensuring refrigerant compatibility and long-term performance. Question 2. Given the circumstances of retrofitting an old R22 rooftop unit in a school, Ramirez finds the duct static pressure exceeds 1.5 inches W. C. Causing low airflow and uneven cooling. The client is also switching to R400 TINA equipment. What is the most critical retrofit step to ensure proper system performance post-installation? A. Redesign and resize ductwork to lower static pressure before installing the new unit. B. Add booster fans to existing duct runs to increase velocity. C. Replace only the rooftop unit with a high-efficiency R400 TINA system. D. Install bypass dampers to reduce resistance in main ducts. Answer. Correct answer. A. High static pressure causes blower, strain, low coil performance and noise. Before installing R400 TINA units, which often require higher airflow rates, duct redesign and resizing is essential per CAM manual. D. Booster fans. B. Mask the symptom but don't solve restrictive design, simply replacing the rooftop unit. C. Risks efficiency loss and compressor wear. Bypass dampers. D. Can harm system balance. Humidity control. Proper duct sizing ensures airflow matches equipment needs, extending life and improving comfort. Question 3. In light of recent developments in refrigerant face-outs, Mr. Chan must retrofit the supermarket's parallel rack system currently using R400 forward to low W refrigerant. The piping insulation is intact and compressors are in good condition. Which approach ensures environmental compliance while minimizing retrofit costs? A. Replace compressors and piping to match new refrigerant. B. Convert to R400 48er after oil and seal compatibility checks. C. Switch to co-transcritical with full rack replacement. D. Use drop-in refrigerants without addressing oil compatibility. Answer. Correct answer. B. R400 48er offers significantly limited debut than R400 4er and similar operating pressures, allowing reuse of existing compressors and piping. Oil seal compatibility must be confirmed per OEM bulletins and EPA SNAP guidance. Replacing compressors A increases costs unnecessarily. Co-transcritical C requires full system redesign, too costly for this scope. Drop-in refrigerants without oil changes. D. Risk lubrication failure. R400 48er retrofit minimizes downtime and meets compliance while preserving existing hardware. Question 4. From the perspective of psychrometrics, is Porto's retrofitting a dehumidification system for a coastal archive room? The system must maintain 50% RH year-round without overcooling. Current equipment cycles off frequently, leading to humidity spikes. Which control upgrade is most effective? A. Add an oversized DX cooling coil for rapid moisture removal. B. Install a fixed bypass reheat coil using waste condenser heat. C. Integrate variable speed fans with hot gas reheat control. D. Use a desiccant wheel without altering existing coils. Answer. Correct answer. C. Variable speed fans allow longer coil contact time at low airflow, enhancing latent heat removal. Hot gas reheat prevents overcooling by reheating supply air, maintaining RH without temperature swings. Oversized coils, they cause short cycling, worsening humidity control. Fixed bypass reheat. B. Lacks modulation, risking energy waste. Desiccant wheels. D. Are effective but costly and complex for small spaces. ASHRAE humidity control guidelines recommend modulating airflow with reheat for precision in archival storage. Question 5. In response to repeated compressor failures after a retrofit, Mr. Davis inspects the suction line and finds oil pooling at low points. The system was recently converted from mineral oil to PO for R400 TINA. What retrofit correction is most critical to prevent recurrence? A. Repitch and reconfigure piping to maintain proper oil return velocity. B. Increase refrigerant charge to improve oil circulation. C. Install an additional liquid line filter dryer. D. Reduce compressor start frequency with a soft starter. Answer. Correct answer. A. Oil pooling indicates improper piping slope or velocity, preventing return to the compressor. R400 TINA with PO needs higher velocities. ASHRAE recommends proper rises and slope adjustments during retrofit. Increasing refrigerant charge B. may flood the condenser and damage the compressor. Adding filter dryers C. helps contamination but not oil return. Soft starters D. reduce mechanical stress but won't fix oil migration. Proper piping reconfiguration ensures lubrication and long-term reliability. Question 6. Across different scenarios, retrofitting hydronic heating systems can involve significant pump inefficiencies. Mr. Patel is replacing a constant speed pump with a variable frequency drive (VFD) pump in a multi-zone office. Which step maximizes the retrofit's energy savings? A. Install the VFD pump with existing control logic and change. B. Oversize the pump to handle maximum possible load. C. Operate the pump at fixed 60 HC for all conditions. D. Integrate the VFD with pressure sensors for demand-based modulation. Answer. Correct answer. D. Demand-based modulation with pressure sensors allows the pump to match flow to actual system needs, reducing energy use per the Hydraulic Institute's best practices, leaving existing logic and change to misses efficiency gains. Oversizing B. increases capital and operating costs. Fixed speed operation C. negates the benefit of VFD. Proper integration of sensors ensures optimal delta P control, extending pump life and improving occupant comfort. Question 7. To illustrate this point, consider retrofitting an older air handler with a new ECM motor in a high-rise condominium. Is green must ensure optimal airflow while minimizing noise complaints. The ducts are undersized and static pressure is above manufacturer's limits. What should be prioritized? A. Increase motor speed to overcome static pressure. B. Modify duct layout and add returns before ECM installation. C. Install balancing dampers to reduce noise in certain rooms. D. Reduce fan speed to lower noise regardless of airflow. Answer. Correct answer. B. Modifying duct layout and adding returns addresses the root cause, excessive static pressure. This allows the ECM to operate efficiently at lower speeds, reducing noise and energy use. Increasing motor speed A. Overworks the system and raises noise. Balancing dampers C. Only shift airflow issues. Reducing fan speed D. Compromises comfort and could cause core freeze up. A CAM manual D. Supports duct correction before fan upgrades. Optimal results. Question 8. Under the assumption that a retrofit aims to improve HVAC in a manufacturing plant, Mr. Wallace is tasked with upgrading ventilation. Co-readings are consistently above 1200 ppm during peak occupancy. The plant's HVAC has limited outdoor air intake. What is the best retrofit strategy? A. Install demand-controlled ventilation with co-sensors and modulating dampers. B. Increase exhaust fan size without altering supply airflow. C. Replace all supply fans with larger horsepower units. D. Add passive vents to increase infiltration. Answer. Correct answer. A. Demand-controlled ventilation adjusts outdoor air based on occupancy, ensuring HVAC compliance while avoiding energy waste per ASHRAE 62.1. Increasing exhaust size. B. Risks depressurization. Larger supply fans. C. Increase energy costs without occupancy correlation. Passive vents. D. Provide uncontrolled air and contaminants. Co-based modulation delivers targeted ventilation improvements. Question 9. The most significant aspect of retrofitting an older chiller plant is ensuring system efficiency. Mr. Singh is replacing fixed orifice expansion valves with electronic expansion valves (EVs). What key commissioning step ensures maximum benefit from this retrofit? A. Set eaves to maximum opening to avoid starving the evaporator. B. Disable superheat control for faster load response. C. Retain original valve control parameters to save setup time. D. Calibrate eave superheat set points for design, load, and part load conditions. Answer. Correct answer. D. Eaves must be calibrated to maintain optimal superheat across varying loads. This improves evaporator efficiency and prevents liquid floodback. Maximum opening A risks compressor damage. Disabling superheat control B removes protection. Retaining all parameters C ignores eaves capabilities. Per manufacturer guidelines, commissioning must match system design conditions for full energy savings. Question 10. Examining the consequences of retrofitting with ERF technology Adams is replacing a conventional split system in a mixed-use building. The project aims to improve zoning flexibility and reduce part load energy waste. Which installation consideration is most critical to ERF performance? A. Use existing refrigerant piping regardless of length. B. Install oversized indoor units to ensure quick cooling. C. Maintain manufacturer-specified pipe lengths, diameters, and elevation changes. D. Prioritize equipment with the lowest upfront cost. Answer. Correct answer. C. ERF systems rely on precise refrigerant control. Exceeding manufacturer pipe specs causes oil return issues, capacity loss, and compressor strain. Existing piping without verification may be incompatible. Oversizing indoor units B. Leads to short cycling. Lowest cost equipment D. May lack the control sophistication ERF requires. Following OEM guidelines on piping ensures system reliability and efficiency. Question 11. In a modern context of retrofitting chilled water systems, Carlson must improve part load efficiency without replacing chillers. Flow analysis shows constant speed secondary pumps causing energy waste. Which solution optimizes performance with minimal disruption? A. Replace all pumps with magnetic bearing chillers. B. Increase chilled water delta T by oversizing coils. C. Use manual throttling valves to limit flow. D. Retrofit pumps with VVFDS and add differential pressure sensors. Answer. Correct answer. D. VVFDS with DP sensors modulate pump speed to match load, cutting energy costs and improving delta T. Magnetic bearing chillers A. Require major replacement. Oversizing coils B. Isn't feasible without AHU replacement. Manual throttling C. Wastes energy and risks uneven flow. Per ASHRAE 90.1, pump control upgrades yield significant efficiency gains in retrofit applications. Question 12. To determine whether a rooftop unit retrofit will meet updated ventilation codes, Holland compares measured outdoor airflow to ASHRAE 62.1 requirements. The system uses a fixed outdoor air damper and occupancy varies widely. What modification best ensures compliance and efficiency? A. Oversize the outdoor air damper to increase minimum intake. B. Add demand-controlled ventilation with modulating dampers tied to occupancy sensors. C. Increase supply fan size to overcome outdoor air resistance. D. Install a secondary packaged unit for peak periods. Answer. Correct answer. B. Demand-controlled ventilation adjusts outdoor air in real time, ensuring IAC compliance while minimizing conditioning load. Oversizing dampers A. Wastes energy. Larger supply fans C. Increase costs without occupancy correlation. A secondary unit D. Is excessive for variable loads. ASHRAE 62.1 recommend DISAV for variable occupancy buildings to balance air quality and efficiency. Question 13. While examining an older multi-zone VAV system, Toro's notes inconsistent supply temperatures after a reheat coil retrofit. Some zones overheat, while others undercool during part load. What is the most likely retrofit oversight? A. Failure to recalibrate VAV box controls after coil replacement. B. Incorrect reheat coil water temperature set point. C. Improperly sized terminal filters restricting airflow. D. Omission of air balancing after duct cleaning. Answer. Correct answer. A. Reheat coil performance depends on proper VAV box control calibration. Without recalibration, zone temperature control fails. Incorrect set points. B. Affect all zones, not selectively. Filter sizing C causes localized restrictions but not widespread imbalance. Air balancing D is important but won't fix control miscalibration. Manufacturer guidelines require control tuning after coil retrofits. Question 14. In comparison with standard condenser fan motors, ECM retrofits in air-cooled chillers can improve seasonal efficiency. Mr. Hughes is considering ECMs but wants to avoid unnecessary capital expense. What should be confirmed before proceeding? A. That existing blade pitch matches ECM torque profile. B. That ECMs are less expensive than PSC motors. C. That fan speed modulation will integrate with chiller staging controls. D. That the existing VFD can be reused with ECMs. Answer. Correct answer C. Fan modulation must coordinate with chiller staging to avoid condenser flooding or insufficient head pressure. Blade pitch day affects performance, but integration is primary. Price. B is secondary to operational compatibility. VFD reuse. D is often not feasible with ECMs. RA guidelines emphasize control integration for ECM retrofits in chillers. Question 15. The effectiveness of a heat recovery retrofit on a DOA system depends on climate and load profile. Rivera is installing an enthalpy wheel in a humid region. What is critical to avoid IAC issues? A. Operate the wheel at maximum speed year-round. B. Include purge sections to prevent cross-contamination. C. Use the wheel only during winter for sensible heat recovery. D. Install desiccant coating regardless of supply air conditions. Answer. Correct answer. B. Purge sections prevent transfer of contaminants from exhaust to supply, critical in humid climates where microbial growth is a concern. Max speed A can cause excessive humidity transfer. Winter-only operation. C. Waste recovery potential. Desiccant coatings. D. Help humidity control but don't address cross-contamination. ASHRAE 84 recommends purge sections for IAC compliance. Question 16. Taking into account refrigerant glide-in retrofit conversions, ISTAKIM is switching from R22 to R407 a medium temp system. What adjustment is most critical for accurate superheat settings? A. Use midpoint temperature between bubble and dew points. B. Set superheat based on bubble point only. C. Measure superheat using dew point temperature for suction line saturation. D. Ignore glide since it doesn't affect the XP operation. Answer. Correct answer. C. Superheat must be referenced to the dew point to reflect vapor temperature in the suction line. Midpoint A applies to evaporator capacity, not superheat. Bubble point B is for liquid subcooling, ignoring glide. D. Risks improper TSV adjustment. Per refrigerant manufacturer data, dew point is the correct reference for superheating glide refrigerants. Question 17. From a practical standpoint, retrofitting a steam to hot water conversion in a hospital requires careful control of supply temperatures. HVACR must prevent Legionella growth while maximizing condensing boiler efficiency. What's the optimal approach? A. Keep return water above 100 Fortydic to prevent condensation. B. Lower supply temp to 120 year-round for efficiency. C. Use fixed 100 Acidic supply to ensure sterilization. D. Implement variable supply temps with periodic high-temp sanitation cycles. Answer. Correct answer. D. Variable temps allow condensing efficiency most of the time, while periodic high-temp cycles kill bacteria. Constant high temps. C. Waste energy. Low temps. B. Risk Legionella. Keeping return water above 100 Fortydic negates condensing benefit. CDC and ASHRAE 188 recommend thermal disinfection cycles in healthcare hot water systems. Question 18. Historically speaking, retrofits that failed to address duct leakage saw minimal efficiency gains. Bennett is upgrading a heat pump but finds leakage of 25% in the supply system. What's the priority before new equipment installation? A. Seal and insulate ducts to meet current leakage standards. B. Increase equipment capacity to compensate for losses. C. Install additional return grills to improve balance. D. Reduce thermostat set points to offset performance loss. Answer. Correct answer. A. Duct sealing and insulation prevent conditioned air loss, improving comfort and efficiency. Oversizing equipment. B. Increases costs and can cause humidity issues. Additional returns. C. Improve balance but don't fix leakage. Adjusting thermostat set points. D. Wastes energy. Account those stress sealing ducts before HVAC upgrades for best results. Question 19. The core principles of hydronic balancing require accurate flow control. Mr. Ellis's retrofitting with pressure-independent control valves PIPs in a high-rise. What is the main advantage over conventional balancing valves? A. Low first cost due to simpler installation. B. Greater flow with less pressure drop at all loads. C. Automatic flow regulation despite system pressure changes. D. Elimination of differential pressure sensors in all cases. Answer. Correct answer. C. PIPs maintain set flow automatically even with pressure fluctuations, improving comfort and reducing commissioning time. Low first cost. A is false. They cost more initially. Greater flow. B isn't the primary benefit. DP sensors. D may still be needed in large systems. BSRIA and SIBS guides highlight PIPs for stable hydronic performance. Question 20. Upon closer examination of an old package door to you, Mr. Foster finds the economizer is disabled due to a failed actuator. The retrofit plan includes installing a high-efficiency unit. What step maximizes free cooling potential in the upgrade? A. Integrate a fully functional modulating economizer with temperature and enthalpy control. B. Install a fixed outdoor air damper set to 30% open. C. Program supply fan to run continuously during occupied hours. D. Add co-sensors to modulate outdoor air only for HVAC. Answer. Correct answer. A. A modulating economizer with temp and enthalpy control uses outdoor conditions for free cooling, reducing compressor runtime. Fixed dampers. B. Waste energy in unsuitable conditions. Continuous fan. C. Increases energy use. Co-sensors. D. Help HVAC but don't ensure free cooling. ASHRAE 90.1 supports economizer integration for energy savings. Question 21. Throughout the course of retrofitting an existing HVAC system in a historic office building, Mr. Nguyen finds the original copper refrigerant lines undersized for modern R400 TINA equipment. The lines have multiple sharp bends and long horizontal runs. What is the best practice to avoid performance loss and compressor damage? A. Reuse existing piping after pressure testing and adding oil traps. B. Replace all refrigerant lines with standard R22 tubing sizes. C. Resize piping per manufacturer guidelines, minimize bends, and ensure proper oil return. D. Install additional liquid line dryers to prevent contamination. Answer. Correct answer. C. Undersized or poorly routed piping increases pressure drop and risks oil trapping, impairing lubrication and compressor life. R400 TINA requires larger diameter lines than R22 due to higher pressure and different properties. Manufacturer guidelines detail pipe sizing and oil traps to ensure oil return. Reusing old lines, A, can cause restrictions. Dryers, D, don't solve piping size or routing issues. Proper piping is critical for retrofit success and longevity. Question 22. Considering the evidence of excessive energy use in a retrofit with a new variable refrigerant flow (VRF) system, is Franklin suspect poor control integration is the issue? Which of the following upgrades would most effectively address this problem? A. Integrate occupancy sensors to modulate zone cooling and heating demand. B. Oversize outdoor unit capacity to reduce runtime. C. Increase refrigerant charge to compensate for piping length. D. Disable inverter compressors to run on fixed speed. Answer. Correct answer. A. Occupancy sensors optimize ERF system operation by reducing unnecessary conditioning in unoccupied zones, improving efficiency and comfort. Oversizing units. B. Wastes energy and increases costs. Increasing refrigerant charge. C. Risks floodback and pressure issues. Disabling inverter compressors. D. Negates the ERF efficiency advantage. Proper control integration is key VRF retrofit success. Question 23. By evaluating the airflow in a retrofit project, ISTISing notes that the existing duct system experiences excessive leakage, causing poor cooling distribution and high energy use. What is the best immediate retrofit action? A. Increase supply fan speed to compensate. B. Add additional diffusers for better distribution. C. Install larger duct sections downstream of leaks. D. Seal duct leaks and insulate ducts to current standards. Answer. Correct answer. D. Sealing and insulating ducts reduces air loss and thermal transfer, restoring design airflow and efficiency. Increasing fan speed. A. Wastes energy and stresses equipment. Adding diffusers. B. Does not solve leakage and can worsen pressure imbalances. Enlarging ducts. C. Without fixing leaks is ineffective. A CAM manual. D and DOE guidelines prioritize duct sealing in retrofits. Question 24. Given the circumstances of retrofitting, a residential heat pump system with a new refrigerant type is Parker observes frequent defrost cycles causing occupant discomfort and higher electricity use. What control change should she implement? A. Increase defrost frequency to prevent ice buildup. B. Use a demand defrost control that activates only when necessary. C. Disable defrost cycles and rely on manual removal. D. Reduce outdoor coil airflow to minimize frost accumulation. Answer. Correct answer. B. Demand defrost activates cycles only when frost is detected, improving comfort and reducing unnecessary energy use. Increasing frequency. A. Wastes power and creates temperature swings. Disabling defrost. C. Leads to coil damage and poor performance, reducing coil airflow. D. Decreases heat transfer efficiency. Proper defrost controls enhance retrofit system performance per manufacturer specs. Question 25. In the absence of an original equipment manual, Mr. Clark must retrofit an older refrigeration system with a different expansion device. What is the best approach to ensure correct superheat control? A. Install a generic ESP with standard superheat setting. B. Use a fixed orifice to simplify the system. C. Measure actual evaporator pressure and temperature to set superheat accurately. D. Replace the compressor to match the expansion device. Answer. Correct answer. C. Accurate superheat control requires real-time measurement of evaporator conditions. Installing a generic TXB. A. Risks mismatch. Fixed orifices. B. Lack adaptive control, causing inefficiency or slugging. Compressor replacement. D. Is unrelated to expansion device tuning. Proper superheat ensures maximum capacity and compressor protection, critical in retrofits. Question 26. Through the lens of energy efficiency, Mr. Morales retrofits a chilled water system with new pumps and variable frequency drives, VFDS. The system lacks pressure sensors and runs pumps at minimum speed regardless of load. What's the main consequence? A. Suboptimal energy savings and potential flow inadequacy under partial load. B. Excessive wear on the VFD and motors. C. Increased chilled water temperature affecting cooling coil performance. D. Inability to control chilled water temperature. Answer. Correct answer. A. Running pumps at minimum speed without feedback results in wasted energy and insufficient flow during varying load, defeating VFD benefits. VFD wear. B. Increases only with frequent start-stop cycles. Chilled water temperature. C. Depends on chiller control, not pump speed. Flow control impacts system performance more than temperature directly. Proper pressure sensor integration optimizes pump operation. Question 27. For the purpose of minimizing refrigerant leakage during retrofit, Blake chooses to use a refrigerant recovery machine and follow EPA guidelines. What additional practice is most important? A. Top off refrigerant charge after recovery. B. Use quick connect fittings to speed up service. C. Leave the system open longer to allow complete evacuation. D. Perform a thorough leak detection and repair before charging new refrigerant. Answer. Correct answer. D. Leak detection and repair prevent future losses, ensuring system longevity and regulatory compliance. Topping off A without fixing leaks is ineffective. Quick connect. B. Help speed but don't reduce leaks. Prolonged system opening. C. Risks moisture ingress. EPA and industry best practices mandate leak repairs prior to charging. Question 20. With respect to indoor air quality improvements in retrofits, Mr. Evans is installing a new ventilation system in an office with high VOC levels. Which is the most effective retrofit approach? A. Increase outdoor air intake without filtration. B. Install high-efficiency filters and maintain appropriate ventilation rates. C. Reduce outdoor air intake to conserve energy. D. Use only passive ventilation strategies. Answer. Correct answer. B. High-efficiency filtration combined with adequate ventilation removes contaminants, effectively improving HVAC. Increasing outdoor air without filtration A. Introduces pollutants. Reducing outdoor air. C. Worsens HVAC. Passive ventilation. D. Alone is unreliable in commercial settings. ASHRAE 62.1 recommends filtration and ventilation balance. Question 29. To what degree does duct insulation thickness affect energy savings in retrofits of poorly insulated supply ducts in a hot, humid climate? Mr. Stevens must decide the optimum insulation. A. Insulation thickness has little impact. Sealing is more important. B. Minimum thickness recommended by local code is sufficient. C. Increasing insulation thickness beyond code minimum reduces heat gain and condensation risk significantly. D. Insulation thickness only affects noise control, not energy efficiency. Answer. Correct answer. C. Thicker insulation reduces heat gain, lowering cooling loads and preventing condensation issues common in humid climates. Sealing A is crucial but doesn't address thermal transfer. Minimum code. B provides baseline, but enhanced insulation improves performance. Insulation also reduces energy loss, not just noise. D. Industry standards recommend considering climate in insulation thickness. Question 30. In summary of retrofitting controls on an older HVAC system is a Patel must prioritize sensor placement to improve feedback accuracy, which sensor location is generally best for supply air temperature control. A. In the supply duct downstream of heating and cooling coils. B. In the return air plenum near the air handler. C. At the thermostat location in the occupied space. D. Outside the building near the outdoor air intake. Answer. Correct answer. A. Supply air temperature sensors must be placed downstream of coils to accurately monitor delivered air temperature, ensuring precise control. Return sensors. B. Reflect mixed air, not condition supply. Thermostat sensors. C. Control room temp, not supply temp. Outdoor sensors. D. Help economizers but don't control supply air temperature directly.